Hello students, in this video we will discuss the chapter 11 of the MMP and section 5. Okay, and we show that the coefficient of the binomial coefficient is equal to the gamma of the phi plus 1 and divide by the n factorial and gamma the p minus n plus 1s. Okay, and we show that test. Okay, then the solutions where n is the non-negative integers is 0, 1, 2 and 3 up to so on. Okay, then we take the right hand sides. Okay, now when phi the n is phi and then the n is 0, okay, we take this combination, and then this is equal to 1. Okay, and then we take the combination of phi and 1s, the n is 1s. Okay, then this is equal to phi, and now phi and 2, this is combinations of the phi 2, and this is equal to phi and to phi minus 1. Okay, divide by 2 pictorial. Here we can write the 1 divide by 1 pictorial, and here we also write 0 pictorial. This is 1 and 1, so we cannot write it this. Okay, and then we write the combination of phi and 3, which is equal to phi and to phi minus 1s, and then phi minus 2. Okay, divide by 3 pictorial. Okay, then we can write in the generalized form, and the phi n is equal to the phi 0 and plus phi 1 and then plus phi 2 and then so on. Okay, we put the value of this value. Okay, then we will get this is 1 and then plus this is p. Okay, and then the value of this combination is p and phi minus 1 divide by 2 pictorial, and then plus and phi minus 1 phi minus 2 divide by 3 pictorial, and then so on. Okay, now we can write this equation and the generalized forms. Okay, then this is equal to phi n combinations is equal to the p pictorial divide by n pictorial, and then phi minus n pictorial. Okay, we can write in the general form. Okay, when we put the value of the n here, then we will get all these terms. Okay, now we know the relations between the gamma functions and the factorial functions. Okay, the relations between the gamma functions and the factorials. Okay, we know the relations like this. This is equal to we have already discussed is p plus 1. This is the gamma of the p plus 1 is equal to the phi factorial. Okay, this relation. Then we will put the value of the p pictorial here. Okay, then we can write these equations in terms of gamma. Let us look here. This is Pn combinations, and then this is gamma of the p plus ones. Okay, here we put the value of the p factorial, and then divide by n factorial, and then here we put the value of the p plus 1's gamma, or in the place of p factorial here. Okay, then this is equal to p plus 1 minus n. Okay, and then the gamma function. Okay, then we can rearrange these equations. Pn combinations is equal to the gamma of the p plus 1 divided by n factorial, and then the gamma of p plus p minus n. We can first write minus n and then plus 1s. Okay, in which we put these equations.